Hi everybody, this is going to be a brief video because I don't feel like I've done a good enough job talking about the bell curve and standard deviation and all that stuff. So here we have a bell curve. This is a normal distribution. And this is, again, this is where SAT scores would show up. And what that means here, and what I don't like about most of these, is over here should be the number of people who have scored this. So in other words, let's just put it this way. I know that our standard deviation, and I'm looking down here, I just looked it up for the 2017 test, is 1060. Excuse me, not our standard deviation, but our mean. It's not working. Our mean is 1060. Yeah, I don't write very well, but that's all right. 1060. So that means the most people, if this were numbers over here, the most people would have scored a 1060, okay? So I know my writing is terrible, and that's fine. But then also we have our standard deviation is 195. So what that means is if we subtract 195 from 1060, we get 865. So that means that this line right here is 865. And if we add 195 to 1060, that would be 1255. So what does that tell us? If the mean is 1060, right here, if the mean is 1060, our standard deviation is 195. That would mean that this number right here is 865. This number right here is 1255. And what that means is all SAT scores right here, 68.2% of all SAT scores are between 865 and 1255. Okay? So once we then know that, we can go up another standard deviation. So if we know standard deviation is 195, let's add 195 to that one. And that would be 1450. So the next standard deviation would be 1450. And if we subtract our next standard deviation right here, we subtract 195 from 865, we get 670. So what that tells you, and I hope this is nobody in this class, if you scored a 670 on your test, on your SAT test, there are only 2.2% of all the people who took the test who scored below you. Now, and that's if the scores are on the normal curve, and they usually are. On the other hand, if you scored a 1450, you know that only 2.2% of all the people above you, scored above you. So what, knowing, again, the mean here, if we know the mean, and we know the standard deviation, and the sign for standard deviation, my hands are bad, but it'd be something like that. That's the sign for the standard, excuse me, that's not the standard deviation. This is the standard deviation. I'm going to Z out of that. So this is the standard deviation. We'll just do that little symbol there. If you know that, you can figure out where you are in here. And we know that right here, this is about 68% of all scores. What we know right here is this is about 95% of all scores. And then we know that between 3 standard deviations is 99% of all scores. Now that is a complete mess, but I hope if you play this again, you'll be able to understand a little bit how anything that falls along a normal distribution, we can put it on this bell curve, and if we know the mean and the standard deviation, we can figure out where everybody else is. So we would, even here, we would say right here, if you scored a 670, you would be in the second percentile, which would be 98% scored higher than you and only about 2% scored lower than you. If you got a 1060, you're right here. That would mean you're in the 50th percentile. That would mean 50% scored lower than you and 50% scored higher than you. If you scored right here, if you scored a 1255, that would mean that, let's see, 13, 14, 15.7, 15 point. So about 16% of people scored higher than you. So you would be at the 84th percentile, right about there. So I know there's a lot to unpack here, but I feel like this has been fairly simple, if a little fast. So maybe watch it again and see if you understand. But I think this is a pretty decent explanation of how SAT scores might fall along the bell curve.